Good morning to everyone tuning in live for this great panel discussion we have planned here. We're streaming live from the East Coast in the U.S. Good day to anyone around the world, no matter what time it is for you. My name is Josh Epstein. I'm the Chief Marketing Officer with Aris, and it's my pleasure to be moderating this excellent panel discussion today. This is part of a series where we call Pulling the Digital Thread, where we explore trending topics and technologies that are shaping digital engineering, digital manufacturing, product lifecycle management, and the broader digital enterprise. All from this idea of a connected set of data and information that comprises what we call the digital thread. So our goal is to bring together some of the smartest independent thinkers from around the world to exchange ideas and have some fun. So we're streaming on a slight delay here to make sure we get some high quality audio. So while we won't be answering questions live, we do encourage everyone to participate online on LinkedIn. Please use the hashtag pulling the digital thread in your posts, and feel free to comment and share your thoughts, ask questions, and our panelists will follow along either in real time or directly after. So this discussion will be recorded and will be available after the event on demand. So let's dig in. So today we're looking at how AI and advanced analytics technologies are impacting the world of model-based systems engineering, MBSE. And so today I'm pleased to be joined with three of the leading thinkers on this subject. We've got Jochen Thomas Mohr, a partner with PwC, Rick Razor, a researcher with Fraunhofer IEM and the co-CEO of AI Marketplace, and Rob McAvaney, my colleague at Aris, who's Chief Technology Officer here. So welcome, everyone. Just to start things off, I'd like maybe each of you to give a quick, broader introduction of yourself, your work, a relevant experience on this subject, and maybe just as part of an icebreaker, share with the audience the most complex systems engineering project you have ever worked on. Rick, why don't we start with you?
Yeah, sure. Thanks for having me. My name is Rick, and as mentioned, I was a researcher at Fraunhofer Institute in Paderborn, Germany for a while. There I held various positions, including the head of the digital engineering group, and therefore I've worked with many companies on topics like product lifecycle management, model-based systems engineering, and yeah, emerging AI in engineering. And currently I'm a co-CEO of AI Marketplace. We are a startup helping companies to search, find, and operate AI solutions. Yeah, and coming back to your icebreaker question, so I think it was a project where we modeled both the technical system, a machine, and its digital twin. So they are modeled in an integrated way. We had a complex technical system on the one side and a complex software system on the other side. So I think this was the highest complexity of MBSE project that I've worked in because of the many interdependencies between real world and physical world.
Great. Jochen Thomas, let's turn to you.
Yeah. Also, thanks for having me. My name is Jochen Thomas Mohr. I'm partner within the PwC, as you mentioned. We're leading there on the EMEA level, basically our product development and PLM practice. Yeah, 20 plus years now in the industry and consulting. Started my career once at BMW, being a powertrain engineer, developing basically the wet components of the fuel injection and the ECU for that. And so since this 20 years now, I'm driving transformation projects all over the globe. Yeah, on the one hand side, at Apple, when we started basically this first Apple iPhone, or on the Xbox, the XP 360, and now of course helping clients in the last 6 years really on the digital transformation journey. And I think coming to your question back, Josh, regarding the most project, when I was a young engineer, the first one I had to transfer basically the four-cylinder engine from Peugeot to BMW in the Harmshorn manufacturing plant, and I had to do everything manually, right? So it was a full manual process, traveling back and forth, loading the data on a stick, and then traveling to the other country and then unload the stuff and so on. But now, if you look at the tier one automotive suppliers at the OEMs, I'm now working at the client where we basically try to really change the complete ecosystem to the software the vehicle solution, software designed vehicle, right? And that means you change from a hardware driven company everything to a software driven company. Yeah. And software is leading in the end, and the mechanical electrical components I'm supporting. And I think what this in the end changes for a company is incredible, because I think you need to reinvent the complete business model. Yeah. And so that's, I think, the most challenging one at the moment.
Excellent. Great examples. Rob, please introduce yourself to everyone.
Sure. I'm Rob McAvenny, Chief Technology here at Aeris. I've been with Aeris for more than 20 years and in the PLM industry for more than 25 now. I have spread the gamut here of things that I've done in this industry, from product development to helping with customer engagements, to trying to set the vision for the future of the Aeris technology. As I said, I've been in the industry for 25 years. Early in my career, I was working on the design of what was then the next generation of global positioning satellites. The challenge there was, okay, you're building a satellite, but that satellite has to be launched. It also has to have command and control from back from Earth. And of course, lots of complex interdependent systems, and also no opportunity to repair this thing once it goes into space. So that presented a very unique to me early in my career, unique and really challenging, thought exercise for how these kinds of systems have to be designed.
Excellent. Well, welcome all three. Let's dig into the subject at hand. Everyone talks about AI. Rick, we've had you on before talking about how AI is impacting PLM. But I think this is a really interesting subject when you think about the history of system engineering and kind of the whole notion of connected digital threads and what you can do is all really conceived of in a time before. At least, before generative AI, before really, I would say the commoditization of data science and the availability of really powerful AI/ML tool sets and skills out there. So let's talk about how this is really reshaping systems engineering and MBSE in particular. So Jochen Thomas, maybe just keeping it real, maybe as someone who's out working with lots of enterprise organizations around the world, can you talk about some real-world examples where AI-driven automation or AI in general has significantly improved the efficiency of model generation and of MBSE programs?
Yeah, no, absolutely. I think two things which I think in the beginning are important to understand. I think one thing is definitely it's all about time to market, right? How to get faster, but stay at the same quality level. Yeah, I think these are the key discussion points, right? Where you can improve in the end. And if you look at the different industries, for example, the aerospace industry, there I think it's about, if you look at Boeing or Airbus, it's really about validating the aircraft system models, right? Where you use AI, for example, for algorithm to basically rapidly creating the testing design iterations, right? And the less design iterations you have, of course, the faster you are. I think that's one element. But also, if you look at the NASA, right, also the same goes for the spacecraft systems, right? It was so complex in the past how to simulate and see if a spacecraft system will work or not. Now you can automate that, and this is, for example, one example, right? On the other hand, in the automotive industry, you look also, right, how you can basically be faster in software coding. That's one real example. I think, you can automate this now with to a certain degree, but also validations like safety performance is one element. Mm-hmm. On the other hand, it's about product compliance in this industry massively. One case is, for example, that you can look if you design a new component or a new module, what are on the global level all the different requirements from our compliance requirements you need to fulfill. Yeah, and check if there are any new laws upcoming and so on. So you can automatically check either on the battery system, for example, any compliance topics. Yeah, that's one element. The same goes, but again, on crash tests, right? Crash test simulation, at General Motors or Tesla and so on. On the other hand, if you look, for example, in the healthcare industry, I think it's about also this validation of the medical imaging devices as an example, right? You get more accurate models running the simulations as well there, and also to fulfill the regulatory standards. And as you can see, all these elements, it's all about at the moment regulatory requirements you need to fulfill, but also how you can validate basically according to your specifications. Yeah, can you fulfill your basically your specification regarding your solution? Yeah, this is I think where you can try to reduce, of course, the time, because I think typically you can achieve like whatever 20 to 40% of time reduction, depending basically overall on the solution.
That's I mean, yeah, a phenomenal ROI. I mean, if you can really get out and quantify that and make that part of a business case. I'm curious, Rob, Rick, and any thoughts on the question?
Yeah, maybe I can take up what we already heard. I think the interesting aspect right now is that with the upcoming or the rise of the large language model, we obviously have to look at every engineering artifact that is based on text, right? So everything that is around laws, regulations, specifications, requirements, that are the things that are highly impacted right now, where we see, I would say, a lot of hype, but already the first rollout applications for example, handling specification documents in different manners. So I can only agree what we already heard.
Yeah, perhaps even let's maybe double click there. Thinking about ways that AI can really actually enhance in the optimization of design parameters. We think a lot of it. I mean, LLMs certainly can play a role in extracting, parameterizing text-based design requirements. But what about the broader subject of optimizing design parameters? Rick, maybe you want to continue.
Sure. I think first of all, it's crucial to understand what system parameters are. So if we're really looking into the way how a system is created nowadays, we have the MBSE mostly in the early stages of the design phase, where we look at the system or overall design parameters. The system contains something like the weight, the size, the power, so things that are really on the high level, right? So and now you can definitely integrate AI to make the full, let's say, exploration of the whole design space, right? So obviously people doing this for decades, looking to the best architecture on the overall system level, right? But now we can automate parts of this, right? And it's getting really interesting if we do not only make the simulations on the MBSE level, rather than integrating later stage simulations like, let's say multi-domain simulations, MATLAB, etc., into the MBSE world, right? Because then we can really explore in a asynchronous way every possible solution using ML technologies to find patterns, and then giving back an assistance to the engineer, which kind of architecture at the end of the day really leads to fulfill all the requirements, right? So this is a way to engineer that could not be possible without MBSE and AI.
That's great, Rob. I know you've talked a lot in the past about the importance of digital thread and use terms like requirements as a service. But I think this in particular, when we're talking about kind of leveraging all the different AI sources to create a whole new set of whether it's parameterized requirements or simulations or the like. Maybe talk about the importance of digital thread and the importance of integrating all of these digital artifacts or assets across the chain.
Yeah, it's absolutely critical, and AI is going to play a big role in helping us understand how all these the parameters and the design space fits together. So we talk about parameterized requirements in the sense that we have a target or we have a range that we need to fit within, but then through the systems engineering process, we are budgeting out voltage or watts or weight these things get boiled down to different disciplines and spread out across many different simulations, many different systems models. And the goal here, the key, is to be able to bring those numbers back together. When we get into a simulation, we know that the target of that simulation, the target result of that simulation, is actually one of those parameters within the requirements. So it's actually a digital thread within the numbers that AI can help us expose, that we really believe has potential to really change the way design is done in the future.
Very cool. Let's sort of a lot of theory here, and Joko Thomas, you mentioned a lot of great examples of the application of AI and how it impacts the overall system design. More on the efficiency side of things, which is obviously a big piece of the value proposition. I'm curious if anyone's got an example where maybe an unexpected or overall innovative design decision was made as part of kind of integrating a modern AI with systems engineering. Any examples out there?
We had at least basically, if you have, we had one client where they basically, and it comes more, I think, to the end also to understand the market demand, maybe, because I think combining what your request, because I think a lot of topics are around also, I have my current product portfolio, but what my future product portfolio looks like, and what's my demand on the client side, how the market will develop. Yeah, and I think we had one client where they actually had classically, I would say, 3-4 different product lines for high end, medium, and low. Yeah, depending on the market and on the consumers. But I think with let's say also optimizing, and we had like a Gen AI possibility to calculate what is the optimal, I would say, future product line of a coffee machine would look like. Yeah. And what are the components? Do you need like milk? Do you need how much coffee you need? Do you need basically 2 different coffee beans? Do you only need 1 coffee bean? Do you need whatsoever? Right? And based on the customer demand, and as well basically on our internal, let's say, product portfolio of the client, we're calculating that the optimal fit would be, instead of 3 lines, 2 lines. Yeah, we have like a medium to high size or a premium line where you can have basically either 1 coffee bean or 2 coffee beans set up, right, and a low end line. And I think this was like an optimizing based on the part numbers, right, and the cost size of the components.
Right.
I think it's not, let's say, a fully Gen AI solution, to be honest, right? But it's more like it's like I would say, let's say, rather general AI.
Rob is always making the point that good old boring AI is still pretty powerful and rather underutilized before we even get to the world of Gen AI. But I think so. Maybe let me try summarizing this, and please challenge me if I'm not getting. I mean, to date, whether you're talking Gen AI or classic AI, I mean, a lot of the value is in time to market. A lot of the value is in making the innovation process much more efficient, faster. Whether it's building models, parameterizing requirements, this world of really enhancing innovation, sort of is still early and is still coming. Although I think Joko Thomas, that's a great example of where AI ML can really kind of impact some decision making process on what you're offering or the like. But looking ahead, and there's a lot of great examples in the beginning, from healthcare to medical imaging, automotive, aerospace. What industries do you think are particularly slow to adopt this kind of technology, and where the most opportunity is in, say, the next 5 years for folks to focus on? Anyway.
My personal experience is, I think we see the automotive industry tries it hard, I would say, to use AI, because there's a lot of, let's say, competitiveness at the moment in the market, right? The Chinese automotive OEMs are very fast in developing new basically cars and vehicles. And the European, North American suppliers need to really push becoming faster in the time to market area. So there's a lot of push, but they have the other problem about that they have a lot of brownfield. The solution landscape is brownfield, so they first go to digitization, right, to go into the cloud and taking this step first, right, to come to really using the benefit of AI. Why you see the medtech industry is still very slow in adapting because the margin is still high, right? But there's a new industry which I see evolving in this market. This is basically the food and beverage or fast-moving consumer good industry, because I think they also now realize what are the benefits of PLM, how to manage my SKU numbers, how to maybe also automatically develop my recipes, right, with new flavors. So they are coming, let's say, managing the portfolio. They are now coming very hard in really implementing these kind of new technologies and solutions. So that's why I think, and for them, it's much faster, easier to adapt, right? Because of a less complex infrastructure, less complex products. So it's much easier to adopt new technologies. So that's why I think this is the industry where you will see a lot of investments going and movement. And of course, I mean, aerospace, they are also trying to help basically on the development cycle, but simply the development cycle is so slow, right? And the life cycle of this industry is like 30 years of a new product. So it means also the adaptation will be slow, right? So I would say fast moving consumer goods is now moving fast, automotive anyhow. And I think aerospace and other industries following. Yeah.
So no,
I maybe
great.
have
Please go ahead.
yeah, I maybe have a little different view on the topic at all, because I'm thinking if we were talking about software in the future, I think in most of the cases we will also have to talk about AI, right? So let's take out embedded software, for example, but otherwise, if we're talking about software in the future, we are talking also always about AI. And I think all industries are using tools for engineering, right? They're using CAD, they're using PLM, they're using MBSE software, right? And I'm pretty sure that maybe not in the next year, but within the next 5 or 10 years, hopefully most of these software, enterprise software, we also integrate AI. So I think from this side, it will be pushed a little bit into the engineering companies as well. And I'm pretty sure that this will be kind of the holy grail at the end of the day. If we are thinking about emerging technologies, now AI, especially LLMs, are trained on large data, right? But only random data from the internet, scraped from everything you find out there. But if you have AI based on a digital thread, based on PLM data, or based on formalized MBSE models, I think this will be lead us to unexpected innovation from the tooling side. So I'm pretty sure that we will see over different industries some kind of a push of these AI technologies in engineering.
Yeah.
I would agree, but I would say that there's different vectors of investment. That some companies believe that they can utilize AI, skip over the digitalization, skip over the MBSE, skip over the digital thread, go straight to AI, and they'll get all the benefits. And I think that's backwards thinking myself. And I would also add that that companies investing in the digitalization side of this maybe aren't paying enough attention to how to leverage that investment through the use of AI and generative technologies.
Rob, could you maybe talk a little more about that? I was going to ask, what are the key enabling projects or technologies, or conversely, what are the barriers to actually leveraging the value of AI? But let's maybe start. I like how you differentiated between kind of the digitalization, or what's called a digital thread, connected data ecosystems, and then on top of that, MBSE and structured understanding of how the systems work. Can you maybe talk about that step in evolution and how it supports use of AI?
Yeah, I mean there's I guess a couple schools of thought. If I could just set AI loose on all my 2D drawings and requirements specification PDFs, 3D CAD models, and costing models and procurement, I could set it loose on all that data separately and hope that it can somehow create some semblance of a digital thread, or I can start to really in a formal way, bring those connections together in a way that that we can have confidence in the underlying data. And that's really what I and Eris are really proposing here, is that you can use AI to help you build a digital thread, of course. And once you have a digital thread, you can much further leverage that thread through the use of AI. But you shouldn't ever skip that step of creating that digital thread. And the reason is because you have a lot of interrelated disciplines, interrelated data, interrelated processes that you don't want room for guesswork. Right, you want to make sure that when you're building product that has to be safe, that has to control your company's risk profile, that you can't just set AI loose and hope for the best. There should be checkpoints and validation along the way, and that comes, at least in our view, comes in the form of a connected digital thread.
Excellent. Yeah, thoughts on that subject, Rick. Yeah, Jochen Thomas and Rick. I know in the past you've talked about other. We've talked about other barriers to enterprises adopting AI, and sort of particularly around security, around IP protection, around concern on particularly Gen AI on hallucinations or similar adverse outputs. But yeah, thoughts on other challenges that the modern organization needs to deal with on the path.
Yeah, I think the most, I mean, at least, and Rick, I guess you have also a couple of nice comments soon on that. I think the one thing which I think is very important in the end is about the skills of the people, right? Because I think one thing, if you do a transformation, if you really want to change, want to be faster, more efficient, you need to change the way you're working, right? So you need to, on one hand side, make sure that the engineers, designers and so on have the right training, that they know how to use AI, for example, that they know how to use new tools, and et cetera, et cetera. Of course, you have a lot of senior expertise there, but they also need to adapt to new technology. And I think that's, on the other hand, also, well, the change management, right? Making sure that the resistance in the people, you need to be managed, right? Because it's not a tech-led transformation. You're not coming, you just change the IT system. I think it's coming, the business needs to have the need, right? To also adopt new technologies and use it because they see the benefit out of it, right? And you need to communicate also these benefits to the people, that they don't lose their job, but that they can do other things besides, right? And also you need to make sure that you get this trust and validation, right? So the trust that these AI models, right, that the predictions are reliable, that they're even maybe better than what you could have done as an engineer, right? You need to really trust this data. And I think that's the other point. Of course, you talk about privacy and cost of implementation and so on. Yeah. But I think in the end, and it later comes to the point, can you scale it? That's I think the other topic for me. Yeah, because on Industry 4.0, I think we saw there are so many ideas out there, but only a few, maybe 10% of the companies really managed to come to an Industry 4.0 end-to-end process, right? 90% of them failed. And so, and if you have not a solution, you cannot scale it, it will not bring you the benefit, right? So, and we learn from that, I think, yeah, that you need to scale it. And that's why I think I like also Rick's comment earlier. I think you need to integrate it in the tool suite. It's rather not have a standalone AI use case here and there, because this will bring no benefit, but you need to integrate it basically in the ecosystem. And then I think it will also bring the benefit.
Yeah, I think to train the people who use the tools at the end of the day is crucial, always crucial. And I think that second big point is definitely data, right? So as I think most know, AI is basically all about data, right? And if you're using a large language model, somebody else took all the pain of the data gathering, data preparing, and so on for you, right? But if you want to use applications inside of your company, right, then you have to prepare your data on your own, right? And for this reason, I think we came back to the point that to manage data within a platform that is accessible, that can share data, that can federate data, this is at the end crucial, right? I think, Rob, you mentioned how important the digital thread is, right? AI may assist, a digital thread. But I think at the same way, it's so crucial to have a thread to empower at the end AI to bring value into the company. And if you have prepared the data, maybe in the future, maybe not right now, it could be interesting how we adapt AI solutions to the engineering methodologies, right? Just because you have, let think AI that can create CAD, it may not know how your company is doing the containment tree, for example, right? So you find that in the data maybe, but you also have to talk to the experts at engineering in these companies for years and bring the internal knowledge of how the methods are applied to engineering data into the solutions as well.
Yeah, a couple of thoughts come to mind. Rob, I know you've talked a lot about the complexity of federating data, and I can think of when you have, whether you're using certainly if you're using an LLM model that's hosted elsewhere, but even if you're deploying on your own, in your own environment, and likewise if you're sharing data with different models or business processes. Can we talk a little bit about the complexity of federating data out and managing who sees what?
Yeah, it is a challenge. I mean, I think most data scientists figure we can just dump all our product related data into a data lake, set AI loose, and we're in good shape. The reality is, much of that data represents the product company's trade secrets. Some of that data may be export controlled. Other parts of that data may be classified through several different government agencies. There's sensitivity to the data that's being represented here, and so we can't simply allow AI loose on this data and expect that somebody asking a chatbot for a highly classified design, we certainly don't want that chatbot to reveal details of the secret. So the answer then is, instead of dumping everything in a data lake, we have to have a federated environment where within that federated environment we have data representing multiple disciplines, multiple phases of the product lifecycle, where they all come together and provide an enterprise-grade access control model that is not going to leak data to AI training or otherwise that would be too sensitive for that kind of use case. So federation is really about connecting that data in a more formal way. It is about understanding the corporate systems you're using and how the data within them interrelate, and then being able to, on top of that, provide an access control model that represents, or that reflects the serious nature of the security of the data.
It strikes me that you can't really talk about AI and systems engineering without also thinking about simulation, right? And obviously, simulation is not new. Powerful simulations have been informing the design process for many years. To some extent, some of this also had to be figured out in the simulation world. But how is AI, transforming the use of simulation in organizations, and how does that inform the way that the average design engineer will interact with advanced simulation in the future? Thoughts?
I can
maybe. Oh, okay.
Go ahead, Rick.
I just start shortly. Yeah, I think so. I think the most common adoption right now is to use the outputs of simulations, right? It's not like you starting simulation, get feedback instantly, even if you use cloud, right? So I think in real world, often we face simulations that may take hours, days, and so on, right? And feeding this results of simulations into ML models leads to, I think, the typical application that you can predict at least with a short amount of time, what happens when you change the input parameters, right? So this is, I think that is currently used in the real world example in many different ways, right? The other thing is that maybe will be very interesting that we can use simultaneous simulations to train the models for products in the future. I think, all the big players are working on that in the field of robotics, for example, right? To generate synthetic data with simulations that can be used afterwards for the product development as well.
Yeah, for me, the big change is the ability for AI to automate the execution of these simulations, to monitor them as they're happening, and understand probably earlier than a human could where this thing is headed. Right. And so it provides for, as Rick said, the optimization use cases. It provides for faster multi-system, multidisciplinary optimization, and the ability to run multi-fidelity simulations is, of course, enabled by the MBSE side of this. So imagine you're running a system simulation that can then dive into a physics-based simulation, figure out how the input parameters are impacting both at the systems level and at the detailed level. Really do that multidisciplinary optimization in a very efficient, very fast manner, and can push the design forward in a positive way.
It's fascinating. Let's pull this back up to the top higher level. Jochen Thomas, you talked about obviously the importance of time to market, of this really transforming the efficiency and the speed of the innovation process. What does this do to business models in general? Like what does this how does this change the way that organizations respond to competitive moves or market dynamics shifting?
Yeah, let me answer the question, Josh, a little bit the other way around. Yeah, if that's So because I think if you look at we do our annual CEO survey every year. Where we talk to 3,000 CEOs, and I think this year, it was clear, for example, that 75% of the companies have started that they want to reach the customers directly, right? So they want to have smart products. They want to be collaborative, right, along the value chain. And on the other hand, these basically companies also said that they need to change the products, right? So they need to change and need to generate a new way how they will generate the revenue in the future, right? So you come more from let's say the market is changing, so the ecosystem is not so secure anymore. So it's not about the clients want to just be faster, more efficient. They actually want to reinvent themselves, right? So as a consequence, it's not about only efficiency and compliance. It's really about what is the business model of the future. And that's I think how the game comes now, right? How to get basically to the customer, how to generate the new right products, how to make your money in the future, and what are the right technologies I use to do this in the end, right? And now we come to the point, the faster you can react, the better you react to your clients or to your customers. It's basically the first to market with your new ideas. And this is in the end the logic where you now use everything what we discuss. It's about how you really come from your first idea very fast in the end to the launch of the product and get the feedback of the clients, use it directly in a simulation. Yeah. Give one example on a different industry, and that's Formula One. I think typically, and just imagine this, typically when you design a Formula One car, it takes 4 to 6 weeks of iteration, but you only have 1 week for the next race. So it's in the end, you cannot change a lot in 4 to 6 weeks because for 4 weeks, you have the same car. One of the Red Bull Racing team, as an example, they managed to be through AI and other functionalities that they can change their car in 1 week completely. And they rebuild the car in 1 week. So every race you see of a Red Bull Racing team, they have a new car, right? While the others have still the same car. And that means they of course they have still the same rules, but from a logic, They're much faster, reacting to the driver, reacting to the racing track, whatever it needs. They even change based on the racing track, the design of the car, right? So you have a Monaco, you have a different car than you are on on another racing track. So that's I think the competitive advantage they now get, right? And I think this is the logic. I think whoever is there better and faster in the end will gain market share.
No, that's absolutely, and it definitely. I think you can see it at that broader business level, but this goes down all the way down to an individual process or an individual component,
Absolutely.
right? It just everything gets accelerated, whether you're a small work group or you're at the macro system. Excellent. I think that's a great place for us to stop here. Obviously, there's a lot of different directions we could take this conversation, but I really appreciate your time. And I look forward to collaborating in the future. I think we have both of you scheduled, both Rick and Jochen Thomas, scheduled for some future discussions in the next several months. And Rob, I always enjoy bringing you along for this these conversations. So thanks everyone for listening in. The recording will be available shortly after the live stream, and want to again encourage everyone to continue the conversation, keep it going on LinkedIn. Please use that hashtag of pulling the digital thread in your posts, and we'll respond and continue the discussion online. So thanks everyone, and look forward to seeing you next time.